Good evening. Hello and welcome to Pharma-info with Shubhashish. Today, the topic which I am going to deal with is on molecular docking, the demonstration, the practical details of molecular docking study, right? Okay. Now, before starting the process, we all know about molecular docking. It's just to know the exact orientation of a particular ligand within the binding site of a target. The target can be a receptor, it can be an enzyme, it can be a DNA also, right? And most of the targets which we are going to bring, during the process of docking, or which we are going to deal during the process of docking, they are being fetched from protein data bank, right? Okay. So I'll come to it. What are the different sites that you need to deal with while dealing with the docking and all. Now, without wasting much time, let us just today I have chosen a particular target here. The target is reverse transcriptase enzyme, and the purpose is to inhibit the reverse transcriptase with a suitable ligand, right? So first and foremost, let us just go to that site where we can get the protein, right? As I said, the target is found to be a reverse transcriptase, right? Okay. So in that case, let me just take you to that particular site where you can get the protein. That is one of the mostly used site is found to be www.rcsp, that is Research Collaboratory for Structural Bioinformatics, right? You can also get it from NCBI, that is National Center for Biotechnological Information. But yes, as we are dealing with this, let me just take you to that. Okay, I have typed here RCSB. Okay, let us spend some wait for some more time, right, so that the page will open, right? Yes, the page has opened now. Let me do one thing. Just a moment. Yeah. I just want this. Okay. Okay. So now this is found to be the site. Yes. Yes. Now it's okay. Now, so this is found to be the site, right? Okay. I think that it has been changed because of some wrong clicking and all. Yes. So this is found to be the site, that is rcsb.org, as I said. Now you need to type that means the query need to be submitted. The query is I need an enzyme called reverse transcriptase. Straight away you can type here reverse transcriptase, REVERSE, reverse transcriptase. But let me give you one suggestion. See, while dealing with a protein, no, you should give an importance, or you should always give importance towards those proteins which are having their active site preoccupied with the ligand. I mean to say the co-crystallized structure need to be downloaded, right? So once you are going to download, once you are going to deal with the co-crystallized structure, so what happened? You are just making the process one step advance. How? Because you don't have to search here and there where exactly the active site is. Rather, as the protein is found to be ligand bound, so definitely with the help of the location of the ligand, right, you can readily get to know about the active site. So you don't have to waste much time in dealing with the, or in defining the active site and all, right? Chalo. So now, as I have written here, reverse transcriptase, okay, cryptase, see, and just press enter. See, definitely the page will open, right? I have submitted my query, and according to my query, these are the possible enzymes. See, around 4,639 structures, right? That RCSP is holding, okay, or it contains, okay, that is related to all the structures related to what the reverse transcriptase, right? Okay, but as I know that and see here what are the information that you are observing. Say this is found to be the code for each and every protein, be it reverse transcriptase or some other protein, right? The code should be there, and that is of four, it's a mixture of Arabic number, at the same time some alphabet and all, right? Okay, chalo. So likewise the code is there. While clicking the code, this will take you to that protein, right? So this is found to be the title for this, okay, or rather the name. What is there actually? See here, it is written complex with some base nucleotide RNA pseudonode, right? Okay, and release date something like this. Method is X-ray diffraction. See, the all the structures which we are going to deal with, they are elucidated with the help of X-ray diffraction study, right? Okay, with no more NMR and all, right? Okay, at this very moment, right? Chalo. So now, and this has been published in so and so journal, and that is this is the page number. The volume is 17, and this is published in the year of 1998, right? Okay. So if we are not aware, or if we don't have the the code with us, it's better to type the query, okay? But if you know the code, right, say now I know the code, right? I know the code of that protein which I am going to bring, okay, for the purpose of docking and all. So that is 1RT2. Say I'm just writing here 1RT2, right? Okay, it is also a reverse transcriptase. So simply, putting the code, okay, this will open the corresponding protein, okay, the corresponding protein, right? See, the corresponding protein is crystal structure of HIV-1 reverse transcriptase complex with TNK651. As I told you that it's better to deal with a protein in which the active site is found to be preoccupied, okay? So in that very case, so here, and that means you are one step ahead. You are one step advanced rather. Why? Because because with the help of this TNK651, you can readily trace, you can readily figure out the area where the active site is, right? The same details are there, okay? Now I'm just opening this one, the information, right? So here, download files, right? Now if we just scroll down, because this is the page in which only 1RT2 is there, and this is the relevant information, like the literature in which this particular work was published, right? Okay, in the year of say 1996, long back, right? Around 24 years back. And these are the informations. These are the other relevant informations, like your the sequence number of the sequence comprised or comprising of how many amino acids, and additional things as well, like water as well as the ligand, okay? So it is having, so at this very moment, so right now we have okay, what we are exactly seeing, that is it contains a chain A, right? If we just scroll down further, we can get another chain, B chain, right? So both the chains are there. That means two subunits are there. One is A chain, the other one is B chain, right? And each chain comprised of different, a varied number of these things, the amino acids, and say at the same time water molecules, right? So the A chain comprised of 560, whereas the B chain comprised of 440, right? Chalo. So these are the informations. Now, as you might have seen here, that complex with TNK651. So definitely, all we want is just to know know the feature or the structural feature of the TNK. So this is found to be the TNK. The 2D diagram is there, right? 2D diagram is there. That is of TNK. So this is found to be the TNK1, having two phenyls, one pyrimidines, right? Pyrimidines. Okay, that to have two ons. We have a etheric bridge here. So this is about the ligand, right? Okay, with the help of this ligand, you can also design some novel kind of ligands as well, right? So this is about, and these are the other informations. If you're really interested, you can go through it, no problem at all. Now let us move to, now let us just fetch the protein, right? We need to download the protein, right? Now one question may rise, that ligand interaction, right? Okay, how do you come to know that before putting it into a particular interface? How do you come to know that what are the what are the proximal, or rather what are the amino acids, okay, that those constitute the active site? That means, what I mean to say, that how this ligand is placed within the active site by means of some interaction, right? And interacting with what? It has interacted with the complementary residues, right? So that means you need to develop an idea, or rather you need to gather those informations pertaining to the active site residues, right? Okay, that can also be done. Say earlier RCSB, this site, they provided us this 2D interactions and all, but right now they have just removed this particular thing and all. But yes, we have a software called drug discovery, right, or Accelerates. That means accelerates, they are providing a discovery studio, right? So there we can generate the 2D view, 2D view, that means the interaction, 2D interaction views, right? Through that particular picture, we can get to know that what are the amino acids, okay, which constitute the active site of that protein, right? Chalo. So now let's just download it first. So you have to download the PDB version if you really want to know the sequence, right? So we have faster sequence as well. So this is found to be the faster sequence. That means a linear stretch of amino acids. Here only it can reveal the composition, right? Composition, no structural presentations, no 3D interactions, nothing. Only the thing is that what are the amino acids, that too in a single letter, right? That means you are not expecting alanine should be kept in the form of ALA, NI, That means neither ALA, NI, nor ALA, rather only A. So likewise, the rest of the amino acids, they're also being presented with the help of a single letter and all, right? Chalo. So we are concerned about the PDB, that is protein data bank. So naturally we have to download this one like PDB format. Okay. So while downloading it, see here it is about to complete, right? It is about to complete. So now let me just take this one 1RT2. So I'll just take that one 1RT2 and just say here I have kept one this thing. So the another folder 1RT2 is already there, right? So 1RT2. So that okay, let me just paste it, right? Because okay. So this is 1RT2. Now, as I told you that yes, so in order to know the active site residues or the interaction pattern two-dimensionally, okay, we have to take the help. We need to take the help of a particular software, that is your Discovery Studio. So here we have a Discovery Studio. I have Discovery Studio here. You need to click it, Discovery Studio 2017. It's a free software, okay, freeware only, right, for academic version and all. Ask me later. And then okay, let me just wait for a couple of minutes, right? It will not take more than 1 minute, right, for the opening and all. So only thing is that you need to bring the protein, okay, in this interface, right? In the interface of this Discovery Studio, you can get it. Just type Discovery Studio in Google, right? This will. Okay, so now let me just. So many options are there, but we are concerned about the protein and its 2D interactions and all. So file open. Then I'll move to this one. Okay, chalo demo. So within this folder, I have kept one RT2 here. I'll just open it, right? So 1RT2, yes. So this is found to be the the quaternary structure of the protein. So here we have the entire protein is there, and from the RCSB, the content says that it comprised of two chains, that is A chain at the same time B chain, right? So that means two subunits are there, and and definitely there is a promising interaction, okay, that has already been taking place. So here we have alpha helix, we have beta sheets, we have loops, we have coils, all these things are there, right? But through this, with this particular presentation, you are not in a position to figure out that what are the different amino acids are there, or rather which constitute the active site and all, right? Chalo, in that case, let me just take you to that platform or to that point where we can readily come to know, or we can gather the information about the active site amino acids. So here you might be seeing that one. So this one is show 2D diagram, right? If I just click it on, see, it transforms this three-dimensional structure into a two-dimensional one, right? So this is the actual, exact molecular view of this of the active site, right? Where so this is found to be the TNK. As I said, that TNK comprised of two phenyl, and we have another, pyrimidine as well. So these are the proximal neighbor. What I can say, these are the proximal neighbor. Some are of A chains, some are of but here it is clearly visible that it is the B chain that is not holding the active site, in which you won't find the active site. Rather, active site is there, and that too in the A chain, right? Because not even a single residue belongs to B chain, right? All the amino acids they belong to the A chain only, and that is why A always you can find A, right? So in each and every cases you can find A. So here, so these are the amino acids. Now this is tyrosine 181 is one of the amino acid in which the pi stacking. Yes, this may be pi stacking, right? Yes, see. Now, if I just take the cursor to that particular point, it shows pi stacking, right? So tyrosine 181, just you have to keep it in your mind, or you just take and make a note of it, that yes, tyrosine 181, because this will help you to track the active site, right? If the protein is found to be devoid of ligand, that is the co-crystal, so that time it is the residues, okay, that can help you out in identifying the active site. So it's my suggestion, or what I can suggest you here, you just take down those or let's just make a list of those amino acids which are found to be the part and parcel of the active site, right? So in that case, we have just here, for my convenience, I'll just write two amino acids. One is your tyrosine 181, the other one is lysine 103, right? Okay. So this is all about your, if you're really interested, you can just take a snap of it, right? So that in future correspondence, this can help you a lot, right? So I don't have anything to do with this Discovery Studio, so hence this need to be closed, right? So I'm closing it. Now let me just take you. So we have the protein with us, and we know about the ligand as well, right? Okay. So now we need to prepare the protein for the final operation and all, right? So we have dealt with the site from where we can get the protein, right? Once you get the protein, then what need to be done, right? Okay. The next thing is bring the protein in a particular platform in which you can just process the protein, right? And the platform is nothing but MGL tools. That means Autodock core platform. MGL tools means Molecular Graphics Laboratory, right? So this is found to be the site, okay, from where you can download. See, as per your configuration that is in your PC, you can download, right? It is already there for Linux. It is also already there for Windows, and source all platforms, right? And even this can be given, or we have a separate version, okay, so which is compatible to any of the environment, right? Chalo. So this is found to be the site from where you can download this MGL tools, okay? MGL tools, that is Molecular Graphics Laboratory tools, right? You can get any kind of version. So here it is 1.5.6, we have 1.5.4, 1.5.7. These are nothing but the version, right? Okay. Now let us just open that one, right? Once you install that one, definitely you will find it within the program files, right? So let me just go to the C drive and just come to this program files. So now I'll just, okay, if we just drop down here, okay, scroll down. So we have MGL tools 1.5.4, right? I'm just opening it. And here, this is the ADT, right? So this is the ADT, okay, that need to be clicked, double clicked, right? And yes, a black page will appear, right? Like your command prompt, like, so here within this black page, you have to click it twice, right? So twice you have to click, right? Now wait for some more time, because it will take some time to open the MGL tools platform and all, right? Yes, it has started opening, right? It has been initiated, it seems, right? And we are using the academic version. Right? Okay. I need to prepare the protein. What do you mean by preparation of protein? Preparation of protein means, you might have noticed that the protein is holding a particular, that means the active side of the protein is preoccupied, right? And all we want is, we just want to check the compound which is there in our mind, or in our pen and paper, right? That need to be developed, and all I want to see is that how it or while docking the compound which I am interested in, okay, how it orient itself within the active site. So that means, as you want your compound to be docked, so that means the active site should be vacated, right? Should be emptied. Prior starting your own business, the active site which is preoccupied with TNK 651 need to be emptied, so that you can just throw your compound within the active site and check its compliability, right? Chalo. So now remind me later, right? And we have, so here 3 versions are there, but this is found to be the default version, Autodock 4.2. You have to dismiss it. Now, so we have with us this platform, right? These are having so many things and all, okay, which are, and if we just click on any of it, so many sub versions are also there, right? So before that, what I need to do is in the MGL tools only, in the MGL tools, I have to create a directory. I have to create a folder, right? So suppose I'm just creating a folder, and that is okay. Let me just take the demo from here, right? Okay, this folder. Let me just take this one and import it. So I'll just cut it, right, and import it within this MGL tools, right? Okay, so within this MGL tools, I'm just importing it, right? Chalo. So it has been imported, it seems, right? Okay, this will take some time. Why? Yes, now. Okay. So I'm done with this. Demo is now there. Demo is holding the protein of interest, right? Okay. So now the protein is there, right? Okay. Now let me tell you one thing that yes, this is the platform for the protein preparation, right? And if we just want to carry out Autodock 4, if we stick to Autodock 4, right? So this is the platform where each and every operation need to be executed, right? But as I said, we are not going to use Autodock 4. Instead, the higher version, that is Autodock Vina, and which is command based. It's not graphics based. It's command based, right? So that is why Autodock Vina we are going to launch here. We are going to deal with Autodock Vina. So that is why, up to a certain extent, we need this platform, and the rest of the things that we'll do in another platform. That is entirely a command based one, right? Chalo. So now the thing is, okay, so now let me just take you to that, as I told you that, yes, we need, see, here is our demo file, right? Let me just do one thing. Okay, so to go away. So this is the demo file, right, where we have kept our receptors and all, right? We have seen that yesterday. We have seen that. Just remove it. So this is a 1RT2, right? This is 1RT2, and this is another one which we have downloaded, right? This one is the old one. Both are found to be same. Why? Because the file size is found to be same, 679 KB, right? Now let me just tell you that yes, as I told you that the active site should uh, be freed up, right? You need to free up the active site so that whatever compound that you were willing to incorporate, introduce for the purpose of docking, that can be precisely and readily docked, right? Okay, until and unless you are not free up the active site, it's not possible to dock your compound instead of the existing one, right? Okay, within the active site. Chalo. So now let me just tell you how the freeing up process can be carried out, right? How you can free up the ligand, right? There are two ways. One, simply dealing with this, dealing with the script of this particular file, right? Script, all I mean to say, suppose if I just click it here and click right click and just do the right click and go for this edit option, right? Okay, one script will open, right? A notepad script will open. In that script, you can find the each and every detail of the particular enzyme and all, right? So, say 16th March 96, the script was developed, right? Or made, right? So now if we just scroll down, okay, you can get so many enormous informations are kept here, and all are pertaining to this particular receptor only. So now if we further scroll down, because it's a very big, huge file and all, okay, huge things are kept here. And those things are nothing but the coordinate information, right? If we just further scroll it down, you can get to know about you can get the information about the helix as well as their composition, right? So what all the, different, these things are different amino acids are there. And if at all, and in addition to this amino acids, what are the other things that are kept here, right? So you need to free up what? You need to free up the enzyme from the co-crystal, that is your TNK. At the same time, if at all any other co-crystals are there, at the same time, the water molecules like HOH, right? So it's better just we'll start from here. So what you need to do is just see, as we found that these are found to be the unwanted stuff for the time being. These are found to be the unwanted stuff because the atom, this is the heteroatom or hetero name and all, right? So we'll just remove it, right? Just delete, select and delete, same thing. Now if we just drop down, okay, let us just drop down because you need to check it thoroughly, right? It should be in a like a bird's eye view, right? Okay, You need to check it because you are in the search of what? Right now you are in the search of those ligands, right, which are found to be unwanted in our future or further proceedings, right? Okay, if I just scroll down, you can get to know, okay, up till now what are the things that we have seen, all are pertaining to your these things like amino acid, right? Still we have amino acid. Now here comes our unwanted stuff, that is the TNK, the co-crystal, right? So we have to select from here, right? Just once you are done with this glutamine from B chain, it is the 432nd amino acid. Now next, the heteroatom TNK starts, right? All the atoms of TNK, right? It is visible. And once we are done with this TNK, then beneath this you can find the HOH informations, right? Which need to be erased, right? Which need to be erased. And so till the end, you have to select till the end, right? From the unwanted, that is from the ligand to the end, right? You have to select and then just simply delete it, right? Okay, now you have already freed up what? You have already freed up the protein from the co-crystal as well as the heteroatoms. That means the water molecules. Now you just save it, right? Okay, let me just give it another name, right? Let me just give it another name. Okay, we do one thing. Instead of this things, no cancel. We just save it like this. Plain text format, right? Plain text format, and I'll just put here free. F for free, because we have already freed up. That means the active site has been emptied. Not only the active site, but also wherever the water molecules are there. Because why we are removing the water molecules is the principle behind the removal of water molecules is see, water being an electronegative or being as it is holding an electronegative atom, definitely it can participate in the formation of hydrogen bonding. So, and we cannot rule out the fact that the water, water is scattered all over this things like the protein, right? So it is scattered all around the protein, right? So it is expected that within the active site also you can find a trace amount of trace. You can find few numbers of water molecules, right? So they may interfere in the process of interaction between the drug as well as the complementary amino acids. So for that very purpose only, in order to avoid such kind of unwanted interaction, we are just removing the water molecules, right? Chalo. So let us do one thing. So in that demo folder only, we'll just keep this one, okay? 1RT2F.pdb, right? I'll just write .pdb and just save it. Now let us just close this one and move to this. See here, these things are there. And see here only you can get to know about the difference in the file size. So this is the original one. That means the co-crystal along with the water molecules. Okay, the whole thing, the whole receptor, the whole enzyme is there. And this is found to be the emptied one. That means here the active site is not found to be preoccupied. Just now you have removed this one. So this is one of the way by which you can remove this, you can free up the active site, right? What are the other ways? And for that very reason, we have to open this MGL tools. It has already been opened here. So what I need to do here, first and foremost, you have to go to this preferences, then modify defaults, and then select the folder in which you have kept all these things, right? So the folder we have named, the folder has been named as like demo, right? Yes, we have given the name called demo. So likewise, you have to type demo, right? So make it default and set and go for dismiss, right? Right now I'm just showing you the other way by which the active site can be freed up, as well as the water molecule, as well as the way by which you can desolvate the protein, right? That means the desolvation, right? Okay. So this is the way. So we have just chosen a folder, right, in which we have kept our compound, our target of interest, right? So what we need to do here now, just open this one, read molecule file, read molecule, then open. It will take you to that folder which you have selected as a default, right? So now this is the free up. This is the freed up. We have already freed up, right? Now let us deal with this, because which is already preoccupied. We have to bring it here. We have to bring it in this interface, right? Now let's see that how it appears, right? How it appears. Okay, it appears. I'll just press D. Okay, so I'll just press D for deep, right? So just now so earlier it was something like fade kind of things, right? So now it has been brightened up, right? It has been brightened up. Now I'll just see that yes, whether water molecules are there or not. Now let me just press atom so that at least now you can readily distinguish, okay, the different atoms which are associated with this particular protein, right? So what? So now we need to see that whether it is holding the TNK with it or not. From our previous understanding, we came to know that yes, it is the A chain that is holding the TNK, right, as well as the water molecules. So we need to check that yes, whether it is still having, yes, water molecules are there. Now we need to see that TNK is also there or not, right? So let's see that whether the TNK is also there or not in the chain. Okay, so yes, the TNK is there along with its atoms and all. So we can do one thing. Here also you can just select, or it's better just you just go to select from string. You just type the name TNK, but here the number got changed, right? So here the number is found to be. Let me just check the number, right? Because you have to be more precise and specific, right? In dealing with uh, the the ligand and all, right? So what can be done is, yes, so it is TNK 999 star. So here, see, because while dealing with this RCASP, from where we got this protein, right, there we found that it is TNK 651, but right now it has been changed to TNK 999. But let me tell you, there is no change in the elemental composition and all. The composition remains same only. So we'll just write here or type here TNK 999, and you have to followed by an asterisk, right? Comma HOH. That means you are also removing. You're also in the process of removing the water molecules, right? So we'll not mention the specific water molecule. Instead, all water molecules, because you are in the process of dissolving the entire protein, right? So it's better HOH. You just put here. You just write type another asterisk here. Now come to this port where atom is there. Here only you have to type one asterisk, right? So add up. Now see what happens to, now things are glowing, right? Things are glowing. So no, okay. So now you have to add. So we have added this one, dismiss, and then go to this edit, then delete, then atom set, right? And continue. Now see, nothing is glowing, right? So all are invisible, it seems, right? So all are deleted, it seems, right? And while checking this, or while cross checking this with this dashboard widget also, you can find yes, there is no such TNK which is still there with this particular protein. We have removed this one. Yes, it is showing, but the thing is that it is partially showing. Why? Because if the amino acid or the residue is there with this particular protein, then it should be there along with this sign, right? But the thing is that, let us just check whether in water molecules, in each and every water molecule, you won't find this kind of the arrow kind of things. Along with in TNK also, you won't find this arrow kind of things, right? So we are over sure that yes, nothing is there which is found to be unwanted, right? So we'll just close it and just we have to save it, right? So file, save, and then yes, definitely the PDB, right? So what can be done here? So we'll just do one thing. We'll just rename it 1RT2 FM, because we have freed up the protein using the platform MGL tools, right? So that is why FM, atom, heteroatom, short notes, and transform coordinates. Okay. Chalo. So with that, we are done with this saving and all. Now we have to delete it because we don't have nothing to do with this particular platform at this very moment. So now in the process of this changing and all, removal of this ligand and all, yes, the receptor or the protein there is a certain change, okay, which is definitely which you can definitely find in the structure of the protein, right? So there is a change in the coordinate. That means the position of coordinates got changed. So during the process of removal of or freeing up the protein from its co-crystal, right, there is a change in the coordinate, right? So that means you need to reshape the coordinates, right? So you need to refine the coordinates, and for this very purpose, energy minimization need to be carried out, right? So the next step is, once the protein is freed up with this co-crystal as well as water molecules, the coordinate has to be refined. Why? Because it got distorted. So as it got distorted during the process of removal or alteration or editing and all, so that is why the coordinate need to be refined or redistributed rather, okay? And for that very purpose, it is the SPDBV, that is Swiss PDB viewer, right? I have with me this Swiss PDB viewer. You can get it because it has been it is given to this academic purpose only, right? You don't have to spend not even a single penny, okay, from your pocket, right, to acquire or to possess this kind of software and all. So this is the SPDVV only .exe because it has already been installed in my computer. So that is why. So this is found to be the icon which need to be pressed. So once SPDVV has been installed in your computer, it is showing this kind of things, right? Okay. So now it has opened, right? I need to close this one, and this is found to be the working window, right? So here you need to procure the protein. Protein means the modified protein, right? Where I have kept this one? Within the MGL tools, right? Where it is? Within the program files. So if I just try to scroll down, you can find the MGL tools here, right? So it's MGL tools 1.5.4. So here you can find the demo, right? So in that demo folder, you can find this free. We'll just take this one, 1RT2F. You have to open it up, right? Definitely say here NB of heteroatom, all these things will. So you have to just blindly, you have to press OK, right? Okay, once this is done, the protein is appearing, right? So now it is there in front of you. The protein is there. So what you need to do, you need to edit. We go to this edit, not edit, rather, I have to select it, sorry. You have to select all, right? Go to select, press all, right? So that the each and everything of that particular protein has been selected, right? So now you have to go to this preferences, and then come to this energy minimization, right? Press it or click it. So basically, it's a kind of conformational study, right? You were refining the coordinates. That means you were just making the protein energy minimized, right? Though we are not using the global energy minimization, but still it's an energy minimization process. And the method that they are using, or SPDBV is using, that is steepest descent, right? So all things remain same, okay, remain unaltered, right? You have to press OK. In a span of 30 seconds, this will be over, right? So you have to close it, sorry. You have to, before closing, you have to just save the script. So come to this file and then save, and then current layer, right? Save current layer because it has been refined. Now you need to just rename it. So I'll just rename it in the form of 1RT2F energy minimized. So EM, right? For energy minimized. So likewise, and .pdb obviously. If you are not writing .pdb, तब भी चलेगा. Why? Because pdb file is there. Okay. Now just save it, right? Okay. So remember that I have given I have renamed it in the form of 1RT2FEM, right? Chalo. So let us go back to this folder again, right? Like demo folder where it is supposed to be there, right? FEM, right? So this is the one. So you need to open it. Why? Because let us just open it first, then I'll just explain why you need to open this one. You have to select it and then right click and then edit, right? Okay. So while going for editing, you can find few informations which are found to be unwanted and which this SPDBV has incorporated in the script, right? So there in our future proceedings, those things are found to be unwanted. So if we just scroll it down, you can find the informations or few lines or few rows in which starts with SPDBV, right? So these are the information that SPDBV utilized or used, right? While going for or while undergoing this kind of energy minimization process, right? So you need to select. So these things should not remain with this particular protein, okay? So you have to select from SPDBVT until the end, right? These are the informations which it used during the process of energy minimization. We don't have anything to do with this particular informations, right? And for that very reason only, you need to delete it, right? So I have deleted and just save it. Save it, right? Okay, chalo. So now we need to deal with this energy minimized protein, 1RT2FEM. Okay. Now let me tell you one thing. So we have with us, now we have with us the target, right? Now for the purpose of docking, we need to, get what? We need to get uh, this, one ligand, right? So we know that we have so many ligands, right? So many existing ligands or drugs are there which are acting as an NNRTIs. NNRTIs. One of them is found to be nevirapine, right? So let us just fetch nevirapine from the net, right? Okay, let us see that whether nevirapine is there or not, right? Okay, let's just go to this Google Chrome, right? Okay, why it's not opening? It's supposed to open. What happened to this? Okay. Anyway, what we can do, that is, we can just make it, okay. We don't go after, borrowing it from the net. It's instead, we'll do one thing. It's better to sketch the molecule and transform its coordinate, right? Transform it, or rather add up another additional coordinate, right? We have to make it three-dimensional, no? So that is why. Okay, meanwhile, it has been opened, it seems, right? Okay, let us just, as we have decided not to, get it from net, instead we'll just draw it, right? So for the drawing of this 2D structure, it is the chem sketch. Yes, the chem sketch is there, which is also freely available, right? Okay, which is also freely available. I'll just open it, right? Okay, meanwhile, let me just close it. So let us just open this so old computer. That is why it's taking more time, it seems, right? So let me just open this one, chem sketch, right? This will open definitely. Okay. Yeah, yeah. Now it's so it starts appearing, right? So it starts appearing. So this is found to be the freeware version, right, of chem sketch, right? So 2012. Now at present, I'm having this 2012 version, right? We have so many versions are there. It's a good software, good software. And we have another freeware like Chem Draw also, like Chem Office also. Okay, we have few online, platform also. There also you can just make it, right. So let me just open it. It is taking more time, it seems. It is not supposed to take this much time, right? Okay, so yeah, so now it has opened, right? Now, we have with us. So this is the interface, or this is the platform where you have to draw the structure of nevirapine. Okay, it is there with me. Let me just draw it. Take two phenyl, right? Though phenyls are not there, but for my convenience only, I've just brought two phenyl rings, right? Phenyl rings here. So I can change it to pyridyl, right? Because nevirapine is a drug which is holding two pyridyl ring system, right? Then I need to make a bridge in between these two, right? Okay, a bridge has been constructed, and then I'll just put replace this carbon with a NH, right? NH is there, okay, and then the bottom portion need to be bridged up. So this can be bridged up, and beneath this we have to put one cyclopropyl, right? Okay, we have to put one cyclopropyl. So likewise, I'm just putting a cyclopropyl here, and we have another carbonyl group here, right? We have another carbonyl group here. On top of it, we have a methyl, right? We can change it to methyl, right? So this is the way, this is the raw structure of nevirapine, right? So now I need to clean up this one. So we can clean up this one, and just I need to select each and everything of this particular structure. Okay, likewise, Control A, Control C, and then I need to paste it in a in a converting software, right? We have a software like called OpenBabel, right? OpenBabel is the one which can just change your change the file type, right? Okay, change the file type. Okay, So because I don't require this MDL or this small file, because for the docking to be executed properly, all I need um, uh, is a PDB, right? So, but ChemSketch can provide me or can fetch me only the MDL or mol file, right? So the informations which I just copied from this ChemSketch, okay, has to be incorporated, pasted here, and I have just kept it PDB. Likewise, convert. Only thing is that you need to ask this software to convert this one, right? It's an offline one, offline server. This is. So now this information has to be copied, right? So I have just copied this information and pasted in a WordPad. You have to go to this notepad. Okay, notepad. Okay, we'll do that one. Okay. Then you can name it like N for nevirapine. I have constructed nevirapine. So N dot PDB. I'll just write here N dot PDB and kept it in the demo only, because demo is found to be the running folder, right? Okay. So with that, we are done with this file conversion things and all. Now we'll move to what? Now we'll move to this Autodock tools again, right? Because okay, let me just check it once that yes, whether it has come or not. Yes, N is there, right? And if you just want to see that how it looks three-dimensionally, what can be done is, okay, we have this is already open, right? So ligand, we have considered this as a ligand, right? So input open. So this is all files, and then I'll just go to this N and open, right? So yes, it has been opened, right? Okay, we'll come to it. The informations just now which has been appeared in front of us, I'll come to it later. So this is the one which we developed, right? Which we developed from 2D to 3D, and how this can be done. I have shown you, right? We have an online software as well that is called ProDRG that can also help you out if you are unable to install this OpenBabel in your PC, right? So it is the online server that is ProDRG. ProDRG, okay, it's a UK based server, right? They can provide you, or they can provide you the converted version of your mol file, right, to PDB. So let us just remove this one first and move to the next part, right? So next part is preparation of the protein for the final execution, right? Preparation of the protein. So before preparation of the protein, we'll just prepare the ligand first. Okay, why? Because it will take us, it will not take much time, right? It will take very short time, right? So ligand input open. So here I am supposed to make it all files. So this is the N open, right? It has been opened, right? And then I'll just go for torsion tree, detect root, right? So detect root, and then once I came to know the root and all, then I can just hide it. Okay, it has been hidden, right? Then I need to add change the atom type. Okay, the atom type need to be should be of 84, because we are running this particular thing, or we are going to import the compound in a platform which is Autodock. So that means Autodock can only recognize the compound which is made up of Autodock type of atoms. So that is why the atom type need to be changed, otherwise it cannot recognize, right? So that is why you need to make it 84 type. I have just made it 84 type, and the charge need to be incorporated, right? So you have to provide charge to each and every atoms which are found to be the part and parcel of nevirapine. So here we are using gastizer. There is you can go for Coleman charges as well, but here we are using this gastizer. So compute gastizer. Okay, the charge has been added. Now we need to save it in the form of PDB QT. Earlier it was PDB. Now additional things that you have you did is you have just added charge. At the same time, you have just changed the atom type to 84 type. So likewise, just make it N, because PDB-QT is already there by default manner. So you have to save it, right? Okay, chalo. So we are done with this preparation of this ligand. Okay, now we'll move to this protein, right? We have to prepare the protein. So this is the read molecule, and then let us just bring the energy minimized one. So this is found to be the energy minimized one. Okay, we have brought the protein. The protein is ready to appear. Yes, it has been. Now it is there, okay, with us. Now same thing here also, you have to just you have to add the hydrogens, right? So hydrogens, usually we are adding this polar hydrogens, the polar only, have just made it polar only, okay, because it is the polar hydrogens, they are participating in the process of, hydrogen bonding interactions and all, right? Okay, so now we'll move to this. Once we are done with this hydrogen addition and all, then we'll move to this changing of the atom type to 84, the one which we did for this ligand, right? Okay, so it is just still it's buffering, right? Because it's a macromolecule. For a ligand it will take a few seconds, right? For a protein it will take even more, right? So now the charges need to be added. The gas stage charges has been added here, and then okay, we are done with this addition of charge and all, and then you have to just save it, right? Save it same in the form of pdb only, because pdb only. Okay, why? Because you may raise the question that why it is pdb not pdb-qt. Yes, we have some other in our we have some other step, okay, in which we can just change the atom type or change the file extension or file type from pdb to pdb-qt. So that is why, though I have just added a charge as well as type of atom, but still I have not changed the file extension, right? It remain as such, like, yes, so like this. So we are done with this addition of charge as well as adding up the hydrogens and this changing of the atom type and all. So with that we are done with this, and we have just saved it, right? Now we can delete this one, right? We can delete this one and come to the next step, that is the grid preparation. So grid is the one, actually you might have heard in QS here, the grid is the one which is used for the measuring of the properties, the molecular properties. In case of 3D QACR, grid is used to determine or to measure the properties like steric field as well as electrostatic field, right? But in case of molecular docking also, they are using grid just to know the interactive residues, just to know the type of interaction that is likely to be taking place, okay, in between the residues and ligand functional group, right? So we'll just go to this grid, and let us see what are the drop down menus are. So macromolecules are there, you need to open. Okay, we have with us the macromolecule in the form of pdb only, that is em only, okay, and now you have to open it. So yes, it starts appearing, right? It has been appeared, right? Next we have to choose it, right? Okay, still buffering, you have to wait, we are not in hurry, right? Done 100%. And then we'll move to this initializing. Yes, now initializing this energy minimized structure, okay. Another port will appear here, pdb-qt. So this is the area where you're supposed to make it pdb-qt, right? Save, because in the next step Autodock cannot recognize the pdb file. It has to deal with what? It has to deal with the pdb-qt of both receptor as well as the ligand, right? Chalo. So now with that we are done with this. Now we have to choose it, right? We have to choose it. This is the one, energy minimized, select molecules. Okay, the selection has been already made. Then just a moment. It's taking some time because we have choose it. We have to choose it, right? And likewise initializing. This was made earlier. This was made earlier. You just see. Do you want to replace it? Yes. You can just go after clicking yes, right? Now let us just bring the grid box. Now before bringing the grid box, you have to locate the grid box within the active site. Now all of a sudden, right now the protein that we are dealing with is not having its co-crystal, so it's very hard to figure out where exactly the active site is. But as I told you earlier that yes, once you are dealing with this 2D view or 2D interaction of this protein along with the co-crystal, you can readily track or trace the area where active site is simply on the basis of the amino acids, right, which you have already figured out. Yes, these are the amino acids which are found to be the part and parcel of the particular active site. So likewise we have with us tyrosine 181 and lysine 103. They are found to be the active site amino acids. So before proceeding further, we'll just select them, right? So that we can readily track, we can readily place the grid in that location only, right? So it is the A chain that should have lysine, right? Okay, let me just select one of the amino acid, right? Lysine. So it is the lysine 103. Okay. So definitely it will appear here. So if we just zoom in, we have to zoom in. Okay. You see a portion of it is glowing, right? Or highlighted, right? Okay. Let me do one thing. I can just take it to this area, right? Yes. So this is the area. So this is the area where lysine is there, right? If we just further zoom it, right? This is found to be the lysine, right? I'll just show you another once again, right? So let me just toggle it off. You just have, focus on this area, right? So lysine 103, yeah, now it's appearing, right? Let it remain as such. Let it remain highlighted, right? Because we can, at least we have to position this, or we have to, place the grid in that location only, okay? So now I'm just asking the grid box to open, to appear, right? Right now grid box is here, but you need to relocate it from here to there, right? So how this can be done? Go to the center and pick an atom, right? Pick an atom. I'll just pick this one. Okay, now see the grid has been relocated from here to there, and you have to just do some kind of rotation and all, so that at least you can ensure that nothing remain outside. Nothing should be there outside, right? So likewise, you have to place the grid. Okay, likewise, you have to press the grid. You have to press the grid, place the grid in such a way so that nothing should be there outside, right? Okay. So likewise, let me do one thing. Center, pick an atom. Yeah. Or here. Just a moment. Pick an atom. I'll just pick an atom here. Yes. Now we have position to it. Okay. So we have relocated the grid. So this is found to be the location where the active site is there. Now what need to be done is go to this widget and just toggle it off. Which one? The lysine 101. Because our purpose is served, right? So the purpose is solved. So likewise 103 need to be toggled off, right? So likewise we have just toggled off this lysine 103. Now what need to be done is you need to shorten the grid size, right? You just make it 24, because we are doing what? We are doing, or we have taken what? Autodock Vina, not Autodock 4. If it is Autodock 4, then grid size can be extended to 126 for each and every dimension, right? But as it is Autodock Vina, the grid size need to be, it should lie within the range of 24, right? I'm talking about the size. So this is our center, right? So size is found to be like this, 24, 24, 24 in each and every directions, right? And the spacing has to be made 1 angstrom, right? That I have already made. Now, once again, you just cross check that whether the lysine is still there with this particular, in that within the grid box or not, right? You just check it once, that whether the lysine is still there within the grid box or not, right? Yes, lysine is there, still within the grid box, right? So we are over sure that lysine is here. Now at this very moment, okay, before saving this, the position of the grid, okay, within the routine, you need to take this data, right? You need to note down this data, because this data need to be incorporated in a config file. So we have made it 24, 24 and 24, and the X center we have minus 9.72, both size and center, both the data need to be taken, right? Why? So you need to note down the data, right? Okay. If you are dealing with Autodock Vina, the data need to be noted down, right? So likewise, we have noted down the data and just close saving current. So we are done with this grid preparation and all. Now we don't have anything to do with this MGL tools. Straightway we'll move to what? Straightway we'll move to Autodock Vina, right? So from where you can get the Autodock Vina? Yes, Autodock Vina you can download simply in the Google chapter or in the Google interface. You just type Autodock Vina download, right? It is also openly available, right? So likewise, close the program. Yes, the program has been closed, this one. And the moment, and it is a .exe file, so things can be readily downloaded, right? And once it is downloaded, you can find the Vina to be located where? In the C drive, right? This should be there in the C drive, right? Let me just check it once, that whether it is there in the C drive or not. It is taking some time, it seems, right? Okay. So likewise, let me do one thing. open this computer and then ask the computer to open this to take me to this program files, right? Within the program files, once the Vina has been installed, right, within the program files you can find this folder called the Scripps Research Institute. So within this folder, if you just open this folder, you'll find this Autodock Vina. This Vina is there, right? And these are the application file, okay, which should be kept in the folder under study, right? Chalo. So now for my convenience, I have just kept the Vina where? Here, okay, in the first page of the C. So Vina is here. So what I need to do here is, just a moment, this is an old file, right? I need to delete this one first, okay. I need to delete this one, 600, delete, okay, all are deleted, right? I have kept it one config. These are the 3 application files are there, okay, 2 application on 1 rich text format. Now I have kept the prepared or the final protein at the same time the ligand where? In the MGL tools, right? So within the MGL tools I have kept this protein at the same time this. So where? In the demo, right? So this need to be copied, right? Which one? The PDB-QT. Henceforth we are not going to deal with this PDB, rather PDB-QT. So this is the PDB-QT. I just take this one, okay, Control C. Now let me just go to this Vina folder, okay, Vina folder, and paste it here, and paste it here, paste it, right? So this is the config file, which is found to be one of the essential things, because all the informations which you're supposed to keep it here, right? So the informations, and in the future proceedings, it is the Autodock Vina that will only recognize the informations which you are going to keep here. Got my point? So likewise, here our protein is found to be 1RT2EFM, right? So this is the thing which need to be typed here. 1RT2FEM, right? Okay. Coming to the ligand remains same, N only. So N.PDB-QT. So another thing out that these things you need to type, right? Now coming to the center, in the X center it is found to be 9.72. So likewise you have to type it. So here in the Y center it is minus 40.294, and in the Z center it is 20.792, right? And for the size, all are kept 24, and exhaustiveness has to be given 8, right? But make sure the grid size should not exceed 24. If it is found to be more than 24, then also it can be carried out, but the number of exhaustiveness need to be raised, right? Okay, chalo, so let me just save it. Okay, we have saved it. Now coming to this command prompt, open the command prompt, right? So here you have to type what? First cd dot enter, cd dot enter, cd space Vina, right? Because in the Vina, create directory Vina only you have kept these things, right? Vina, then enter, again type Vina space, within the config file all are kept, right? The informations of the grid and protein and ligand, right? Config, then config dot txt space, you are expecting it to be in the log file, so like, okay, then log dot txt. Okay, we are done with this typing and all. Then press enter and see what they are doing. Scoring functions, it starts analyzing this one, right? It's going on, right? It's going on. It will take hardly, because it depends on the size of the grid and all. So as we have kept it 24, so that is why it will take hardly 1.5 minutes, not even 1.5 minutes. In a span of 1 minute only things will be over, right? So we are done with the docking. So this is the advantage, and this is found to be more accurate, the Autodock Vina, compared to the earlier version, Autodock 4.2, right? Autodock 4 actually. And Autodock 4, it is usually taking more time, right? More time, as the grid size is more. You have to run separately like a parameter file, and then you have to deal with grid parameter file, then docking parameter file. I'm talking about this Autodock 4, which here in this case of in case of Autodock Vina, you don't have to do such things and all. So once we are done with this, see, it generates 6 confirmers, and we have with us the energy as well and RMSD. Okay, all are here. So these are important, the energy values and all. Okay, so this is found to be the highest one is found to be minus 9.7. But if we just so this is here. Now let us see that what it appears here. The same thing in the log file you'll find what? In the log file you'll find the energy values, the one which you can find here also, right? But we need what? We need the the different confirmers, right? The confirmers, because the confirmers with those confirmers only we can get to know about the pose. So likewise we have to write a few additional things here. That is Vina underscore split space input space out dot pdb qt. So you are dealing with the output, no? 6 outputs. Okay, now press enter. Now see what happened. Yes, now it has the same folder has provided 6 different confirmers. In that 6 different confirmers, out of these 6 different confirmers, this is found to be the least energetic one. Now, so we are done with this docking operation. Now what next? The output. The output, where you can get the output? It is the PyMol. That is also freely available. So it is the PyMol software, okay, through which we can study or we can analyze the docking process, right? So analysis can be done with the help of in PyMol. Analysis can be done in Chimera as well. Analysis can be done in Discovery Studio as well, right? So, but PyMol, as far as my suggestion is concerned, yes, I strongly recommend stick to this PyMol. Okay, I'm not getting some honorarium from PyMol. Okay, but still PyMol is very user friendly, it seems, and the features are also good. Discovery Studio as well. So now it has opened, right? Now let me just open the folder in which all the confirmers are kept, right? That is in Vina only. So see, yes, go to this Vina, you can find, and you have to just make it all files, right? So all files, but even though all files, why it is not showing all files? It is supposed to show all files. Yes, now all files are there. But do one thing. Now in that Vina folder, as we are dealing with, as we are going to analyze this Vina folder, right? Now let us bring or let us put those PDB files within the Vina folders, right? The PDB files which we dealt, okay, earlier, right? The PDB files which we kept where in the NGL tools, right? So within the NGL tools, you can find those PDB files. Go to this demo. You can find those PDB, okay? 1RT2 FEM, 1RT2, both the things. That is with ligand, without ligand. I'll just copy it and paste it here. Let me just paste it here, okay? It has been pasted, right? Okay. Now what need to be done? First, I'll just open the this one. Open this 1RT2, right? 1RT2, that means with ligand, right? So with ligand, okay, this has been opened, right? So with ligand, all the water molecules are there. And let us see that where exactly the Nevira the TNK triple line is there, right? Actions preset and then ligand, right? Go to this ligand. So hide this ribbon, right? So this is found to be the one. This is found to be the one in which the TNK is there. If we just zoom in, you can find this kind of things, okay? Now let us go back to this Vina folder and get those. I'm sorry, this is not the one. Okay, get those Get those confirmers, right? Confirmers came out of docking study, right? Okay, go to this. Okay, all the confirmers. Okay, I'm selecting all the confirmers, 6 confirmers, and let's see where exactly they are placed, right? Okay. So it seems that all are found to be superimposed. All are found to be superimposed on top of this TNK. So this is found to be the TNK, right? Okay, let me just take do one thing. Let me just take this label option. Go to this wizard. This label. Okay, I'll just label it. Okay, this is NK TNK 999, right? And these are found to be the confirmers, which are found to be unnamed, right? So it seems that all are found to be superimposed. All are found to be superimposed, right? So that means with that, at least we can conclude that yes, TNK999 was found to be one of the ligand of this NNRT, of this reverse transcriptase. But as we have taken the standard one like nevirapine, so definitely the nevirapine is also occupying the place which is for this TNK999. So it's a successful operation, it seems, right? So likewise, just get the features, and you can just see now it is something like this. And if you can hide all these conformers like this, you can find only one, right? Nevirapine, right? It seems that the least energetic one, I'm talking about the one which has got minus 9.7 kilocalorie per mole of energy, right? So this is exactly superimposed on top of this, these things like this TNK999, right? If you want, you can just go after this removal of this. You can remove this one also, right? You can remove this TNK999 as well, right? Just select it and it can be removed, right? No problem at all. Okay, and you can just remove it from here also, like your display sequences, right? Sequences, and from here only you can get to know about this TNK999. Yes, TNK999 is there. It has been selected, right? And just press right click and hide everything, right? So it goes off, right? So with that, so this is the one that is the nevirapine, and it seems that it is occupying the active site. Let us just, we know the one of the amino acid, right, of active site, that is lysine 103. Let's see that how far it is, okay, from lysine. So it is lysine in the form of K. So see, this is found to be the lysine, and this is found to be nevirapine. If we just check the distance, with that at least we can say that whether it is in close vicinity or proximal vicinity of this lysine or not, right? So for that you have to go to this wizard and then measurement, right? Measurement, and then you can go for this. Yes, I'll just take anything, right? Like this, and this is lysine, no? So this, you see the distance is 4.4 angstrom, right? So it's very close. So with that we can say yes, nevirapine is occupying the same site as occupied by the co-crystal, that is TNK999. So this is found to be the, and if we just want it to be like to make it a surface view, okay, surface view, this will take some time, okay, this will take some time. So this is found to be the surface view, right? Let me just tell you the surface view and all. So only thing is that you have to go to this show, then surface. This will take some time because the surface, no? So let me just do this, make it short and just see how it looks actually. Actually how it looks, right? So this is the actual thing, right? This is the actual thing. You see, yours compound, right? Okay, where exactly nevirapine is there, right? Okay, so show nevirapine in sticks form. Where exactly it is? Yeah, this is found to be the one, right? This is found to be the one which we are after. So it's better. Let me do one thing. Action. Sorry, is that? Should okay. Let me just go to this and just. Okay. It is somewhere near here, right? It's somewhere near here. So let me ask this 1 or T2 to get me to that place where exactly the ligand is there, right? So I'll just hide the ribbons and all. Okay, so this is the one, and if I just keep it as such here, nevirapine is still here, right? Nevirapine is still here. Show nevirapine in the form of sticks. Okay, so just a moment. Let me just check where exactly nevirapine is here. Nevirapine is appearing in the form of sticks, right? And if I just ask this computer to get me the surface view, right? So it is showing me the surface view. Now you can clearly see that where exactly the nevirapine is here, right? Okay, so this is well within the pocket, right? This is well within the pocket. Right? Nevirapine as well as this TNK triple nine, right? So these are the various features that you can, or various posts that you can generate, right? This can be added up, or this can be incorporated in our thesis as well as the articles, manuscript as well. So with that, we are done with the analysis of this docking, right, using Autodock Vina. I think uh, that you have got something okay out of this discussion and all. Please navigate with this particular software and all so that you can um, uh, develop a better understanding, right, of the fact and file that is there within the docking and all. I think that you have liked my video. So if you really like my video, don't forget to press the like button. And please do subscribe my channel, right? Do subscribe my channel so that you can readily get to know that the upcoming videos, get to know about the upcoming videos and all. So thank you for your kind patience. Thank you.